Hey viewers, good morning. Good day. So my name is Daniel Kakasepa. That is my mascot. So now I've released the first video on the first video. Remember, please like and subscribe to the channel. That is very important for me to keep on getting updates. But I'll be dropping updates every weekend. We'll be following me up every weekend. We'll be dropping updates on different maths questions. Very maths with all student of Santander University. I love you all. Please like and follow and subscribe to my channel from other university across the globe. Like and follow. So let's go back to what we have today. On the board you can see we have the topic called set. Now set, some students like particular when I talk to some students that will complain about set. Now a set is a group. A set is a group of well-defined objects or a collection of well-defined objects. What about a well-defined object? Sometimes we say, okay, a group of well-defined objects. I don't understand. Simple. A group of well-defined objects. Now, let me break it down to the normal thing we usually go to the market to buy. Now, your mother sends you, say, go and get me a set of spoon. When you go to the market, we just decide to buy a set. They will ask you set of what? They will ask you set of what? You can't just say I want to go and buy a set. A set of what? A set. Is it a math set? You see it. Everything has is it a mathematical set or a set of spoon? Now that set, the user is concept because the object is well defined. The object has a purpose. That's why we call it a set. Now, because you can't just go and bring a spoon, a single spoon and call it a set. No. The particular object has a purpose and they are in group. They are in group. Now, human beings, I can put a department there. Go and get the set of mathematics department. When you get there, the department are a set. You can say go to the school is a department. The school, each department is a set. In this school, you see, each department is a set of engineering students. They are all selected because they have a purpose, a set of well-defined object. The object is well-defined. The object is not just now. From there, we now go to prime numbers because this prime number is something that students can. What is prime number? What is odd number? But it's very simple. Prime number is a number that has only two factors. Two factors, one and themselves. Now, what are such number? E.g. example of such number. When you say number has one and themselves, these are number that nothing can divide them. No number can divide them. They have only one and themselves. E.g. one. Remember, one is not among. One is not a prime number. One is not a prime number. Take note of it. When it's a least prime number, don't list one. Prime number start from 2, 3, 5, 7, 11, 13, and so forth and so on. Now, to see this number here, nothing can divide them apart from one and themselves. 11, no number can divide 11 apart from 1 and 11. That is for that. Now let's go to even number. Say even number is a number that can be divided by 2. Sorry. Numbers that can be divided by 2 without remainder. This number does not have remainder. These are numbers that only 2 can divide and there will not be remainder. So when we talk about numbers that going to divide, there will be remainder. These are not prime number. E.g. examples of those prime number: 2, 4, 6, 8, 2, 4, 6, 8, 10, 12, 14, 16, 18. These are numbers. You see, these are numbers. So on and so forth goes to infinity. Now, these are numbers that 2 can divide without no remainder. Now, apart from these numbers that are here, I don't think between 8 and 10, there's no number that between 8 and 10 there we have 9, and 2 cannot divide 9. When 2 divide 9, there is always a remainder. So now we can now move on to odd number. See, odd numbers that cannot be divided by 2. When to divide such a number, there is always a remainder. There must be one or two remaining. There is always a remainder. These are what all this explanation is being needed in sets, because we are going to go do a lot of example. I remember in my previous video I did a lot of example, but I think we are going to see take more here to give us the proper understanding of what we are looking for. Now please listen. What numbers say? What numbers? The numbers that cannot be divided by 2. E.g. we have 0, 5, 7, 9, 11, 13, 15, 17, 19, 21. Now, these are odd numbers. These numbers, 2 divided, there is always a remainder. There is always a remainder to these numbers. These are it. Now, we now go to whole numbers. What are whole numbers? That will be a question. Now, what are whole numbers? Say whole numbers, these are positive integers starting from 0. They are positive integers. You see them? These are positive integers starting from 0, 1, 2, 3, 4, 5, and so on. These are whole numbers. Sometimes many students they ask what are numbers, they'll be looking at you, and it's true. And it's true. So we know, and it's true. Now, whole number, these are all positive integers starting from 1. So starting from 0, 1, 2, 3, 4, and 5, and so on. Then now, let's go to our one of our main business. All these we are need them in set, because I'm gonna ask you list the set of odd number in the set. List the set of odd number. List the set between 1 to 30, or 1 less than 30, or greater than 30, and so forth. That's why all this expansion is being needed. Now, let's go to one of those types of sets. Types of set. Now, the type of set we have a singleton or not set, we have the universal set, we have the subset, we have the complement or prime set, we have the linear of a set, we have the intersection of a set, we have the element of a set. Now, we're going to start now from the number 1. We're going to start with the singular or not set. This is how we're going to do it. I'm going to start this. There's still more. There are power sets, there's equivalent of a set, there's disjoint sets, there's a difference of a set. These are other types. But I'm going to add them as the video continue. This is where is it 1 to 7. Now as the video continue, I'm going to add the rest. So I'm going to be solving questions on each of the sets. Now I think we're going to know as we continue solving questions, you will get to know it, you will get to see it, you will be having a lot of questions. Hope you understand this. A set is a group of well-defined objects or a collection of well-defined objects. And although prime number, so please you are advised to pause the video and put it down and at least try to recall it again. Then we'll talk about whole number, which is their positive integers. I'm talking about type of set. I told you that this row 1 here is just 7, but they are more than 7. They are power set, they are subsets, there's a lot of them. So I'm going to work on those ones. So now let's go straight to the singular unknown set. Let's go straight to the singular unknown set. I'm coming back, so we are going to take this as we explain, we give example, explain, we give example, explain, we give example. That's what we're going to do. That's what we're going to do. So explain, we give example. Okay, now this is it. Now I think we have 7. What is it? Is 8. Now I'm going to be in each of the explaining. I'm going to be giving example. That's why I give this space. You can see the space on the board. I give this because I will answer. Explain. I'm going to take one example. But please try to subscribe and go and take on the other one, because the other part of it, I give a lot of examples for you to solve. You can actually solve this example. You can pause the video, copy the example, and try to solve them, because in mathematics, solving is what makes it perfect. Solving. Don't forget to solve. Always solve. It's very, very vital. It's the most important part of it. Don't forget to solve in mathematics and always solve. Don't forget that. Okay, now let's go. Element of a set. Now, this is also a part of it. Element of a set. See, these are the numbers that belong to a set. They are the numbers that belong to the set. What are those numbers? Now, a set. Now, the elements of the set are 1. The element of this set is set A. This set A. 1, 2, 3. These are the elements of the set. I'm going to say about writing the but I just decided to write it again. 1, 2, and 3. These are the elements of the set. Then now let's go to single. I'm sorry for the rest. I wrote singleton or non-set. Please take it without non-set because I actually do different things. Now, singleton. So singleton. See, these are sets that contain one element. Now, we know what is called element already. Now, we already know what is called element. Now, these are sets that contain one element. Example. Set A has only 1. We can call this a single set. Singleton set is a singleton set. These are sets that contain only one element. Now, let's go to non-set. See, these are sets that has no elements. It's been denoted like this or like this. Nothing is inside. They don't have any element. This is what I say a set that has no elements. Then now how about the universal set? There is a set that contains all the elements in the subset. I begin to imagine a set that contains all the elements in the subset. Okay, what is that subset? The thing is, it's getting interesting, right? Now, see, a universal set is denoted like this. So, but many people use different sign to denote it. But it's denoted, is this, it's denoted something like this. There is a set that contains all the elements in the subset. Now, I can say, let me just put a little, I can say, okay, set A, can do something like this. I'll say 1, 2 to 10. Then I'll say set A, contain 1, 2, 3. Then set B, 1, 2, 4. Now, these are subsets of this set. Why? Because all the elements here, found in set A and set B, you can see it in this bigger set. I hope you understand that this figure means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's what it means. Now, subsets. The set got it from a universal set. We do this example. Now, remember, subset. This is set got it from the universal set. This set is gotten from this universal set. That's what I call it subset. Now we can see our universal set, something like this, is giving us A, B, C, D. Then these are universal set. Our subset set A is equals to A, C, and D. Now you see, this is a subset of this. Why? This element here is found here. The element you see ACD is found, ACD is found here. Are you getting me? It's found there. The union of the set. Union of the set. Say combination of two subsets without repetition. Combination of two subsets without repetition. Now, what do you know what a subset is? Now, set A let's say set A contains A, C, and D. Then set B contains, now let's take a set from here, 1, 2, and 4. Now, 1, 2, and 4. These are solid subset, this is subset. Now, union of the set is denoted somehow. Say A, union B. Now, combination of the two sets without interpretation. Now, that statement sometimes it often confuse students. Yeah, often confuse students. Now, because students will take it as without interpretation. Now, what it means that if you see a number repeated itself twice, whether it's this one, or we have 1, 1, perhaps 2, 2, repeat itself twice, you have to pick only one. Don't try to repeat the number again, just pick one. Now, from that, what does it mean that now we have A, C, D, 1, 2, 4. One more example, please. I would like to check my other channel and get the example. Now, intersection of the sets. Intersection, see, taking the common elements between two subsets. I think in case if you want to pause and write down, you can pause it and write it down. Let me take this side of the board. Now, intersection, we are taking what is common. Only what is common. Remember, what is common between two subsets. Now, let's use these two subsets here as example here. Let's take set A. Now, this is it. 1, 2, 3, 1, 2, 4. Now they say intersection. We are taking the common element between two subsets, sorry to say. Now it's denoted as A union B. Sorry, not A union B. It's A intersect B because it's intersection. Now, what is common between these two? Look at it. We have 1, we have 2, think we have 3, we have 4, we are done. Because we're only taking what is common between the two subsets. We're not taking anything much in it. Then complement or set or prime. Complement or set, say element found in the universal set but not in the subset. Element found in the universal set but not in the subset. Now let's take an example. The universal set 1, 2, 3, 4, 5. Then a subset A 1, 2, and 5. Then now, universal, this complement is denoted somehow. Denoted like you can see, is complement or A prime. You are saying A complement or A prime. Now, we cannot move. Now, let's follow the explanation. Element found in the universal set but not in the subset. Now we're not going to look at the universal set. What are the elements found here that are not here? This will call those elements the complement of the set. Now look at this. We have 1, 2, and 5 here. What are the elements in the universal set that is not here? Let's call those elements out. We have 1, we have 1. We have 2, we have 2. We have 5. We have 5. But we have 3 and 4, so I'm going to write it down. 3 and 4. You are saying it. Now, these are the what? Universal, the complement of the set. These are the complement of the set. Please, what you do for me, I want you to like and subscribe. My name is Daniel Akakasiaka, like I just said. Subscribe to my channel. The name of my channel is Daniel Akakasiaka. Akakasiaka Daniel, I'm sorry to say. that also subscribe my channel. Please like and share the video. Introduce me to your friends. Just coming up. Please let's go to 500 subscribers. Please. I know we can do it. Much love. I'll be coming back next week. We'll release my next video next week Saturday. On Saturday, we'll get there on Saturday. But this is what we have for today. Hope you like and subscribe. But on Saturday, we'll go a deep bit more, and we'll do a lot on Saturday and Sunday. Oh, tomorrow is Sunday. We'll see you. We'll see yourselves there. So please like and subscribe. Don't share the information. Don't keep it to yourself, please. Share the information to whom it needed. Please, my student I'm a student of SDU Southern University, a mathematics student. So I would love you to also support from SDU from Southern University, Nigeria. I want you to Ozoro. I want you to also support me and subscribe. Thank you. One love.